All right, hey everybody. I got some content ID flags on my last couple streams, so hopefully this, whatever it's called, lo-fi, no copyright by chillhop.com, Spotify playlist won't trigger anything. Over the past couple days, I'm gonna show you this real quick. Let me switch scenes. Past couple live streams, I was thinking of a way to move a table to a table. And, when you think of normalization, most people only think of the data, but we really have to take a step back and think of the processes. Like, how do we normalize processes? And this solution is not what I wanted. It's what basically an A and a B, and I'm trying to make it one thing, and that is not how I want to do things, because I want to make modules and normalize that process. So basically what I want to create is a module A and a module B. Module A meaning that I can take any table, view, any data pipe, any file, or anything and convert it into a format. And I'm going to start off with JSON because it's easier to use, more lightweight than XML. So I want to take something and spit out JSON. And then another module, I want to take the JSON and give it to something that will do whatever it want, whether it's going to send it to an API using execute external scripts, Python, or it's going to take that JSON and parse it out to call a procedure. We're basically going to query something. So we have a set of data, a set of configs, and then send it forward in our system. Or, BCP if we really want to go that route for file output, or even, back to the Python route to a file output, whatever we want to do, right? So instead of the data point mapping and the data set action and that kind of stuff, I figure I have to take a step back and really create something that can create a script before I attach actions to move the data. So this is the piece of the system that's missing, that it takes a while to think about, to come up with the module type process, but eventually you just stumble into it and you're like, you know what, this is the piece that I need. So I created a script domain in my subject types. So every subject has a realm, class, family, type, and a base table. So the script realm, script class, script family, script type, I'm going to give those specific classifications to let me know if it's the beginning of a giant script, if it's a grouping. So I'll have a select group with, a data point, data point, data point, data point, close that select group off to know that this unit is complete. So it's really drawing boxes inside of boxes. And that's what we can do via recursion. So the actual script table might look something like this, where, we have a select statement that might be part of the group select common taxonomy, and then we'll have actual column names in here. And the other thing that this will let us do is if we define a select data set, right? Oh, kitty. Meow. If we define like a select data set, select statement, or even root statement, what is preventing us from taking that predefined block and just relating it to another query entirely? So in the very beginning, it's going to take a lot of data entry to start building that tool set, but then the containers get reused inside of, we would just keep reusing it, So I want to create something that gets databases, data sets, and data point names, and eventually I might have something else that wants that plus something else, and I already have that base to start with. So the relationship table that I have is basically going to allow us to take these single script items and then relate them to build an actual statement. And because I'm calling this a domain, when I have that script table, I get all these other options like script flags, script names, script addresses, identifiers, all sorts of stuff, which allows me to go further into the configuration. Because like I said, everything has a realm, class, family, type. So I can have a script flag configuration for the JSON piece that says, hey, this is include null values, or this is without array wrappers. So when I'm building this code to generate data set, or to generate JSON for right now, we just have to add the different types that we're looking for and start adding if logic or case type logic to build this very powerful data set returning module. And same with the script names, or the script name shared attribute domain xref. I'll be able to define aliases, so I can take a select statement, and maybe it's the Rome class family type tree. I can take that, put it in here, and give them different aliases and say, hey, I want this to be a very generic alias, so no matter what data set I'm calling, all these aliases line up so they go to the same procedure. So it gives us a way to funnel data into a specific ingestion process through the use of aliases, and just a ton of power. So before we get started, actually I should get chat up just in case. Boom. Hopefully that dings when someone says something. First thing we kind of want to do is look at, a query that we might want to build. So we have the aliases, we have the from statement and some joins. The tables have aliases. We have specific conditions. We have aliases in front of the data point name. So there's all these different little pieces from an actual select statement that we can, parse out and say, oh, this is how I want to build something. And then, we might have where data set name is not null. So I have 32,000 right now, and I know I have some gaps. Sweet. And then what we might actually do, depending on how we want to format that JSON. So if I do for JSON auto, right, and I execute it, darn it. It builds an array based on our joins. So this becomes an array, and this becomes an array. However, on the outside, same thing. Because it's too long. Should do top 100. There we go. Now I get the complete list of things per element versus the nested array. And let me try to run this query again, even smaller. And I'll just run the internal query. So that's different. Name of the database. And then we have an array of data sets that has an array of data points. So it's really, how do we want to ingest this? So we have two different options that we have to think about when we're defining the script itself, because realistically, it's just a for JSON, and where does it go? Is this a container? So this data is inside. Maybe this isn't a container and the for JSON is right here. So we do get a different format just by using the relationship table to tell us where it is, or the grouping the containers to tell us where we should put this code. And then finally, at the very beginning, looking at basic SQL syntax, the implicit join from way back in the day versus these are more explicit joins. We're specifically telling it what to do. So what I want to do is show how far the SQL engine has come. So let me take these on statements and turn these into ands and turn these lefts into commas. Now this is basically an implicit join or a cross join. The implicit side means that you're just letting SQL do its thing. You're not telling it exactly what to do. Left join, inner join, full join, etc. Instead, you're moving your on clause further down to create your filtering here. So we would get these huge data sets, Cartesians, and then the where clause would filter it down. But the important part is we basically have the same query, and when we execute it, let's see, we get the same. Why are we sorting? Oh, because of the null. Let's take this away. Oh, because there's no null on here. Oh yeah, there is right there. Let's do a basic statement, where clause, order should not matter. We're basically getting the same execution path. It's choosing to do inners versus lefts, whatever, because we're giving that specific equal instead of attaching it onto it. So here's another way that we can approach that particular script creation, is thinking of from groups instead of just join groups. So we can create the same type of output depending on what we need. And what this also allows us to do is, because we're creating the scripts and we have a where type grouping and a select type grouping, we can look at this script structure and look at the relationship and automatically build indexes. So because this is being created, we know we should probably add an index on here, including what's being returned, because we're getting scans down here. So we almost develop a self-optimizing system at this point, the more we use this get data set and push it forward. So the main goal of me doing this is so I can take external data, external databases, AdventureWorks, WideWorld importers, etc., and build a data set from that, and then move it wherever I want. And going back to this, it's a very important having that select function or that where function, so we can put a function around the data point or the column in case we need to transform it. So we want this script generator to do something that just gives us this. All we want is this. We don't really care about how it's doing it, but we need to think about the different tools that we need to do it. So I actually have to add data. Filter that down, and let's copy this. I own this. We have a root realm. We have a snippet. We have a group. Oh. item. One through four. I don't know what I might need this for. The idea of the classification is to start off pretty basic. If you can see what you're doing, then absolutely fill out the full taxonomy. But if you cannot, if you don't really have a complete picture, which in this case I see the basic aspects of it, but I might need another classifier here, or to change these classifiers. Unassigned is perfectly acceptable. That basically just tells us, hey, you know, at a later point in time, we can reorganize to provide additional functionality to the code that's creating our code. So these will line up 1 through 4. And I'll just have this here. So we'll have JSON. So we'll have root t-sql. So that'll be 1. And just think about this again. So we're creating a script. It doesn't have to be SQL. Oh, that's fair. Maybe we want to generate Python, and it's not going to really execute. So we're not going to have this return. We're going to have this generation that will be moved. Or, hey, maybe we are creating an execute external scripts. So we're going to create this little block inside of external execute scripts that's going to then return the JSON. So very powerful, not just for SQL, but we can do whatever we need to do. Maybe we're generating Node or JavaScript code so that we can put that code inside of Python that will call an API and execute that SQL. So we can really manage everything from our central system and just let our system automatically propagate outward. Python, let's see, snippet group item. Let's just do Cartesians 2, 3, 4. We'll do JSON. Two, 3, 4, 2, select 3, 4, from snippets groups items for select from, and then where. And then we'll probably do joins. Because in our join group, we might have to do multiple join, like from my current table to this additional table, and my current table to this tertiary table. All right, 7 through 18. Now for this, actually. script family. Do I have that tree yet? Table value function, get script, tree. No, it works on the type. Darn it. Okay. Let's just do this hacky. So JSON select from where. Sweet. t-sql Python. Oh. Nope, we don't want join. t-sql Python. Let's get Python now. Let's just do t-sql and say we're in 2019. And last, join. Darn it. Sweet. So we need the tenant, the family ID, and we will double this up. And I'm basically just creating a Cartesian of what I actually need, because I want to do comment and function for select from where, and JSON I want common, but I might not need function. Sweet. So then I can remove this guy. I want function from select from where. I no longer need t-sql. Let's do an inner join. Is that it? Select from a from function would be a table value. This would be a scalar. This could be a scalar. And we'll just do lift and inner join will help us for now. So now, I'll bring this back over here. Okay. T-SQL root. I have some snippets, which will be my kind of overarching thing. Groups and specific items. Sweet. So let me copy this. Let's see, this will be what I want to build first. So let's just start. I'm gonna have a root script of 1. It's my type ID, which will be 1. I'm gonna say this is a root t-sql Microsoft 2019 script. What I'm gonna call this, I want to call this the what's that called? System schema. This query gets a this query will get the database, dataset, and data point name, basically. That's what I want. And then inside of there, we want it to be, want it to return as JSON. So this is kind of where I have this reuse going on, where I can create another record, and I will find, let's see, JSON. Let's call a snippet common. So that's 2. And the snippet, I could say subquery, but I really like to say snippet is like, hey, here's the beginning of some sort of snippet of code, and then inside it'll do something. I could have said subquery, but that kind of loses its purpose when you're not thinking about SQL. So this will be a JSON wrapper, and it will be, let's just call it include null. That's it. Include null. JSON wrapper include null. And I'm not really giving these key names yet. Maybe later when I create an external application that will help me build these from an interface, something that will make more sense. As for right now, I'm just trying to essentially create this. script. So I have my JSON wrapper, which will be this. That's an interesting concept. So inside this JSON wrapper, we're going to have a select group. That's common. I'm going to call this select star. Inside the select star, I will have an actual item. Select star group, select star as a data point. So this will be, right now I have defined this script. I have say, hey, this is a wrapper. So a JSON wrapper, what we can say is at the very end, it will build the internal. At the very end, we basically need this, the suffix, because we have a select grouping. Inside that select grouping, we have the star, which won't have any flags, no alias or anything like that. We'll just call it star. And then we'll have a from grouping, or from group. Common from group. And I'll call this a from subquery. We won't have a where, so then we can look at this from subquery. We'll have a select group. Select database, dataset, data point, group. It will have an item, which will be database name, dataset name, data point name. That will end that grouping. We will have a from database group. From database item, since we're calling a very specific table. And actually this is not a table, view. Let's say select view, just to make sure we're being specific. That will end from, And we can create a join group. Oh, do I have one? Nope, no problems. Wait. 11. Actually, should have done this. So we'll have a join. Let's think about that for a moment. So join's kind of complex because it's reaching out to something else, but this can easily be defined as a specific join item. So I think the inner and left items don't really make sense, but the groups for inner and left make sense. So the family 17 makes sense. So I have a left join group. Let's call this in the hierarchy of boxes. This is a left join group. And inside here, we have a specific item for this left join. Because it's not really, we could have a left join and then a snippet inside of it, but then we're already building select statements, so that kind of is already taken care of in functionality. But then in here, we really have a left join, and we have a basically a from item. So that will be our from. Then we have an on, which is a where. But our join is in the family. So in the classification where I had these unassigned, the question is if I move the join over to the class, then I will have from and where in multiple areas here, and they might actually conflict, because how do I tell the difference between an on, which would be, hey, if I belong to this specific group, this join class, then I know it's an on, versus a where, but it doesn't really, because a where grouping will also be defined in here. So I think I'm going to keep the inner and left group. And then the items, we'll have join items, and we'll have join common, which will be a table. We'll have join item function, which will be a table valued function. And we'll have a join item for on. And we'll need a group for on. So 17 join on. Okay. Okay. Hope that made sense. So 17 is our group. we're going to have a group of on. Item 18. Maybe I don't like common. If you don't like it, be more specific. Item that is a data set, an item that is a function, and then I'll have an on group, which will have another guess just an on item, because I'll have two of those. You know, let's see how that works out. Let's see what we can do with that. And kind of a little back and forth is starting to create something. Before we can see if that actually was what we needed. Instead of having just a join for my family, I might actually have an on family. Because I know I might need a with family. Interesting. We'll see how that expands. So let's go back. So we have a left join group and left join, data set, select view, group. Left join, data set. We'll just call this join data set. Kind of repeats. We'll have our on group. This will be data set and database ID, or data set and database. Join item. set database ID. Sweet. Let's repeat that. Left join, data point, select view. It's a group. Join data point, just a data set. On group will be data or data set ID and data point data set ID. Let's make sure that I did this right. Nope, I'll make sure I have that ID at the end just so I know that if I'm ever using something that has the same naming structure, data set database ID to database ID, I can reuse this particular section. So we just make little containers and start reusing the subcomponents. It might not make much sense right now until we get a couple done, but first let's build the damn thing. On group join item. So this join item will be a data set ID, and I don't have one of those. This join item, data point, data set ID. I think that's good. I'll bring this back over. Now I have to relate everything together. So for relationship structure, where I will have script, actually I can send the name script to script relationship, SCR to SCR, 1. Functional relationship, provide some sort of function. Direct relationship. And what defines the relationship? They're just members of the above members of that relationship. So how this would look is now I really construct the query itself. So I know, because brand new data set or records in this data relationship structure, I know that it's 1. I mean, I will double check, but yeah, I know it's 1. Okay. So the system owns this, because the system is going to be generating the scripts, not some external application. If an external application wants to use the system data, it has to have proper authorization. This is the relationships specific data set number, so we don't need to fill that in. This is the primary key and the specific data set number of the parent. So that will be these. I'll say 1 and 8, 5, 8, 9. This is the child. So under this full schema query name that we have, we're going to have a child That is a, let's say, should we do, I think the JSON wrapper should be attached to the from subquery. Because if it's a from group, that'll be the end of it. Yeah, let's plug that in last. So let's just create the, because we can always just adjust the relationships. Most of this will be the same. It'll just be trying to figure out where in our code that it makes the most sense to place it in the relationship. So in our overarching script, we're going to have a select star group. So that is 3. And the specific data set number is the same. Now the sequence won't matter here because they're direct relationships right now. Actually, yeah. Just because. What relates to the select star group? Well, the actual select star as a data point does. So what relates to the select star group? The select star data point. It's the first one in that group, and then that group basically ends. And then we'll do a from subquery. So that, okay. Trying to think if I should actually have a wrapper around here. That kind of does make sense. Just a generic grouping mechanism. This group has a select, a from. Maybe I'm overthinking it. So what else? 1 to 3, let's say 1 is also related to the from subquery of 5. And this would be the second one in the list. And I use multiples of 10 in my sequences just in case I ever have to. This is part of the unique sequence or the unique index. In case I ever have to reorder these, I don't have to, I can make it 19 or 9. I have this decent gap, so it helps me. And then I can order row number times 10, update, get them all back to multiples of 10. So my from subquery. Has a select group. My from subquery. Actually, my select group. Oh, that's 6. My select group has 7, 8, and 9 data points. My from subquery 5 to 6, 6, 7, then 5 to 5. My from has a select view. My subquery has a join. Looks like my unique index isn't on here yet. My join has a data set. My join has a group. The group has one on item to a second on item. I'm curious if I want to approach it that way. Oh no, because I have flags. I can say, not just flags, I have reference types. I can say greater than, less than, equals, anything like that. Even if it was an in, I can make my join item a specific value type group if I already have the values from the incoming. Okay, this works. This works. Maybe. I guess I don't have these built. There we go. Okay. Script to script. Functional relationship. Direct member. Data relationship, type ID. Generic integer. So what I'm doing is I'm going to create a procedure really quickly. That's going to be a recursive procedure. I'm going to pass in a top level item. Data. What should I get from here? I want the child select. Oh. Data relationship. Primary key. Child. Implied. Simple enough. Is this recognized? Oh, man. Okay. It's not reference data, it's relationship data. Okay. So, data relationship, primary key, parent implied. Misspelling. We have an incoming script ID. It's going to see what children there are. It's going to take that child and print that child's name. And if that child has any children, it's going to recurse. So let's try this. All my code goes in interface main. I want a new procedure. Script. Let's say we're going to iterate through the children. For the incoming parent. One was the first one. Select star group. Star is the data point from subquery. Subquery contains this group, which are these data points from this group. I wonder if that's even necessary. Select items from the select view. Then we actually need a left join group because there's no group on a from, but there is a group on like a subquery. Yeah. All right. All right. Let's see what other information is going to help us out now. we want a script type ID. Oh. This is the only thing that's using it right now. Let's see if we can say marker. To help us better understand what's happening. This can be null. So when I first execute this, I'm not going to pass anything. And then what this will do, we'll say before we print, we'll have to do it as soon as we enter in. If at marker is null, begin. Let's give it a double. If it's not null, sometimes recursion, a little hard to see flat. This will help us give some sort of marker to it for the development process. And now I can concatenate the marker and the script name to give us a better understanding of what's happening. And then I will pass that marker in. Yeah, because we want to add to the end of it. So it should look a little better. But now with this guy, I get the type ID. Table value function, get script tree. We're not filtering anything out. The marker, I want the child name, hyphen, what it is. now we can see the little indentation going on to actually give us an idea of where things are set. So we're going to leave the marker in here for now at dynamic script. All I want to do is initialize it just in case it is null. I want to make sure there's something there. So now our logic comes into play. After we figured out, basically, let me close this down. I'll start commenting, get relationship type, iterate through children. If child exists, call this dot procedure again. Get child information. Get child taxonomy information. Sort code. If family. What is that? If select group, four, five, six, add select to query. Let's see, since SQL is very friendly, so we're designing it for SQL. We might want to abstract all of this out to figure out whether it's for Python or not. You know what we could abstract out later. Paint the picture and then pull the patterns out. So let's just do, every time we add something, let's give it a return. That will help us format and see what's going on. Yes. If it's select group, if it's a from group, select group, add select query. If it's a from group, add from to query. If it's a join group, add type key name plus join to query. Let's just see where that takes us. Actually hate all this stuff. This is a good, cool part about queries, Microsoft SQL is not really dependent on the white space, so that might help. Select from, select from, left join, on join. Okay, so we have an on group that didn't really fit in there. Select for on join, left join. This actually looked like it's coming together a lot better than I expected for that first run. Hell yeah. But that on join, even though it is a group, it's not allowing us, or it kind of gets in the way. So we might want to think about reclassifying what this is, which will help us control this better via data instead of continually editing code. It is a group, so maybe it's not an on or a join group. Maybe it's an on group, and then we could have a with group. So that sounds a little better. So we have 18. Oh yeah. Get my bearings. I want this. Make sure I'll save that. This is now our procedure. This is that procedure. This is our execute, and this is going to be my little tool belt for this. So I can figure out my join group class of 3. So we're going to keep the class of 3 except for on family 17. Duplicate family 17, make it on, and that new ID will be 30. Duplicate 17. make it an on group. 19, and then 30 will actually belong to 19. Left join, no more on join. So we can add some more code to this. If it's an on group, I mean, actually, I can already see a pattern developing. So let's take care of that pattern. If realm key name equals group. I'm gonna if family key name equals select. Some of these little grouping mechanisms, and I'm going to adjust these comments because that was kind of a pain to edit. 1, 2, 1, 2. Keep my comments really close, even though it's not close to the code itself. It makes it easier when copying all this stuff. So now I have, if this is a group, then we'll figure out what to do. So if it's a group, select from, join on. Yep. Because when we have a snippet, a from snippet, hopefully I classified this correctly. We're going to have a from snippet, which will be from. And we might have to pass an incrementer or actually give the from an alias. Oh yeah, we can give the from an alias. So on a from snippet, we'll have this. And then we'll execute the recursion, which will do its thing. And then we'll have the same if statements after. So we can actually encase it. And that will kind of be like JSON. If this was a JSON item, then go ahead and encase or append for JSON and go check flags and everything. So this is starting to work pretty well. Now I do have to create some other data, which won't be so bad. What am I filtering? I am filtering for reference, because I need to add some reference data to our particular script. So I am adding several items. Script to data point. I will need script to data set. I think that's good for now. Is this relationship? Yep. What do we have? 5 and 6 again. Direct. And if you're wondering why I don't do this in the actual relationship structure, is because this really depends. When you think of data, you have two pieces of data that are independent of itself, and then you have like properties of that specific data that's very much fused together. So in order for the script to actually work, this is the data point, that item, this is the data point it has to belong to, or this is the data set that it has to belong to, versus a script. I mean, those are very malleable type items, or a person to a group. Like they change jobs, they change roles. It's not, it's two independent pieces of data coming together versus dependent reference data or referential integrity. Like this needs to be related to exist properly versus this can be reordered and reorganized. It's not very, it's a loosely bonded type relationship. So 5 and 6 added again. And I'll just do member. Until it proves otherwise. Should I go in? No, let's just do one piece at a time. One piece at a time. So now I have this group. Let's add another chunk for item. So a select item we would have to we know a select is going to be a data point. Ooh, if it's common, it will be a data point. If it's an item, if it's select, Script to data point. Relationship. Direct member. What will we need out of here? We will need the script reference. Primary key implied. Declare add data point ID. Declare add data point name. Dataset ID, dataset name. If it's a select, the data point ID is going to be that. Select data point name. Interesting. So let's start making some notes. To get comma delimited stuff operating properly, we're going to have our post child execution. And since we will say if it was a select group, trim the last value from the SQL script, aka remove trailing comma. If from snippet, add closing plus alias. Let's get some notes just so we do not forget. So if this was an item and it was select and it was common, we're going to figure out what data point it is, grab that data point. We will add alias lookup in a little bit. Really, the point is trying to actually just get this to execute. And then we are going to add to the SQL script the data point name plus a comma. Oh, I'm gonna have to make that note. Last two values, comma, and char 13. So actually we are going to look at the end of the string and say, hey, if this is comma and char 13, remove it. So that will help us. Because what will happen is we'll have our select group come in. It will call this, and eventually the SQL that comes back will be the comma delimited list. So we have to kind of think of context. We're still in the select group area. So now for this, if it's a from item, and it's a common item, honestly, I think the only thing that we need to do, because we work in patterns, is replace data point with data set and make sure data set is there properly. So from common, what we will have to do is now add some more data. We'll have our script tree. Our reference tree. Dang it. Realm key name is item, so let's filter this out by items. Nope. We'll have a join data set. Let's go back here and finally take this group and add it as a reference point for our first query that we're trying to create, essentially. So we want to figure out 3 object IDs. Dataset ID, dataset name from dataset specific dataset number. What do we want? Ooh, okay. So we're gonna have to add a flag to say, hey, this is a synonym, to make sure that we're adding a synonym item to the beginning of the data set name. Sweet. Might as well just get everything we need at once. Sweet. All right, from database select view. So script ID is 11. Reference type ID is to data point, data set. So since we know all these are the same, we really only need to focus on 7 and 8. So if it's a data set, we need an 8. Reference type is 8. This is the implied number. So database goes to the database select view, which is dataset ID 112 with specific dataset number of 20. Let's give it a sequence just because we'll execute this so we have something to copy. Next, we have a join data point. So 18. 162. Script source 18, same type of relationship, different data set ID. Script 13 goes to data set ID 137. Script 13 goes to data set 137. Excellent. Now we can look at items. Go. Script ID 15. Different type of relationship because it's data point. So this is going to be 7. It is going to be, what are we at? 15. Join database ID. So database ID is a big number. And it's now specific data set number 25. Working with one relationship table is a little difficult at first until you start thinking of it's not one ID to one ID, but they're pairs of IDs, and you don't need to foreign key them, which allows us to just add and remove many different tables into this relationship structure without adding more data sets, schema changes, all that stuff. So script 21, data point to data set ID. Nope, sorry. Data point data set ID. So data point data set ID is 3829, 3829. Script 16, data set database ID. Data set database ID is 3727. Script 20 is just data set ID. Three 725. Script 7. Database name 3629. Script 8. Oh, script 9. Data point name 3832. Script 8. Data set name 3730. Oof. Okay. Save it. far did we get? Oh. So we have a misfiring select. Just adding a comma. If we just look at the creation, it says unassigned item, select common, star. So this will be a special case. We can ignore that for now because it won't be common. Actually, pardon me for just jumping all over the place. Makes sense to me. I am going to take star away from the comment type because it is not a comment type, and I'm going to give it an all type. Select star, which is 4. Let's see what family ID that's from. Script family ID. Script class ID, script type ID. Family is right. Family 9, 13. So family 9 needs a new type. That type is 34. Yep. There we go. It is starting to come together. let's do that. There we go. Beginning. Have to add it in there. Get my children. But then I come out. Take away that comma. Does it work for this? Yep. Keep adding the comma when I come out. Take out the comma. But do add the new line carriage return, the char 13, just so we get that nice little format going on. So our from gets a comma, which doesn't make sense. So it's probably just the copy paste code that I did up here. And it is. So we could take that out. So we did not specify this. Family, begin. We took the on out, but we didn't take the data set out. So I believe that's why we are getting left join, and we should have a table, which we don't because we'll set that up. But then we get a data set join. That's that item. We're coming in, join item, unassigned, join data set. So if I'm in my item, join, we're actually going to do the same thing here. If it's a join, and it's a data set, then that's the same code. So now we're starting to see another pattern is I just had to copy and paste this code so this can be taken out and say, you know what, all we need is a script ID, a data set ID, and we're going to expect some sort of formatted piece of information. So this can be abstracted out to a function, and actually all we need to pass it is a script ID because that's how it gets the data set, knows the relationship already. So at a later point in time, we can take these two out, replace with functions, which means we'll probably do the same thing for the data point. I'm guessing is the reverse. Without looking, without looking, I'm just going to copy this data. Because it's an on item. So the on item will be a data point. Except for this, add join type. So right now we'd have to do equals. And the other side of things is if it's an item on, probably gonna have to do the same thing. Darn. Oh, that would be item on. And why isn't this firing? Nope. On join. Let's see when on join is being created. Item join on. We're getting on join. Join. Ah. Almost. So that rip is wrong. That trim is wrong. So what are we doing? That's adding the left join. That's the on. That's the on. Group on. So after group on. Okay, the actual output kills it, so on join. Let's see what that's doing. Join. Group on. Group on. Nothing needs to happen. Ooh, it's looking good now. Okay, let us see what this is called. Group from common subquery. Let's see if we have a from. Aha. That's the difference. That's my mistake. This from group, it's not a group, it's a specific from item. So, what I classified as a from group is not true. It is a from item. And it's the from group. From group. Wait. Nope. Oh, let me catch my bearings. From it's a from common item. And then the group from. Group from. Group select, group on. Group from. And I know we're going to have to make this classifier, so we will ignore that for now. And what happens at the end of a from, we will need to concatenate the alias because SQL doesn't care. We could, we're just going to concatenate the alias. So we're going to say n plus alias. But I need to readjust that very specific item. Going through this, where taken a few hours to build something that's just going to create data sets for us. But it's the data-driven aspect of it, so we don't need to write any more code. The code's done. Why do it over and over again? Now we can send some data to a table that will start returning us data sets. That's the biggest piece of the puzzle. That's what we all do all the time. Hey, I want a custom report. Well, guess what? Here you go. Here's a custom report. Item from common from is 14. 14, 14, 14. From subquery. Oh, it's already there, it looks like. Nope, something's not classified right. From database group. From database item. What else would a from have? Okay, let us think. So I have a from statement. When would I want to make it a group? Because if it was a function, it would be a little different. So I think this is a case of too many things. So 10. So I don't think I need 10 anymore. This is from subquery. Oh, shucks. Close. if it's from, add from open. If it's an on group, add on. I believe in you. Oh wait, where's my from at now? So it's from item. Item from. Left join, left join. Left join. So is synonym what other script configuration flags do we have? Actually, let's not do that unassigned. This is a data set. Script configuration dataset. Script configuration JSON. Script configuration data point. Yeah. Dataset JSON. Include all values. Let's do 11 and 12 because we're getting right near the end. Aliases. Who cares right now? I just want a functioning query. That's what I want. Functions without aliases. I'll save that for another live stream. So before we add our data set, actually let's find data set name. Where are we doing data set names? We are doing it in the from and the join. So we want to look up script flag config dataset is synonym. If it's a data set, or if it does not have a flag defined, we're going to say no, nothing to do with that. And actually, this is another note I want to place, is that there should be a rules iteration here. So we don't have to keep adding these new things every time we add a flag. What we should be able to do is create a series of functions and then attach the script to a series of functions, like go check what flags you have enabled and act accordingly, if that's a true thing. So we might not only have these, but we might actually replace this with a single flag that says, is additional processing necessary, or just say everything gets additional processing. That would be the most ideal way to handle this. Here's the other data set piece. We're going to inject that there. We're going to gotta kind of imagine that we didn't really use many variables for this entire thing. Most of this is data driven. We're doing some sorting because it doesn't know which way to go, and even this, actually, we can make a relationship between a type and a particular process or function or piece of code in action. But then we would be dynamically executing all of these pieces over and over again. So I think maybe having this, and maybe I'll do something where I make it more data driven and see what that does. Like what's the actual difference between the two, between coming here and filling all of these out or abstracting these pieces of information into a table itself, where we have the ins and outs, because then it's just a series of executions, essentially what the engine is, what the database engine is, executing to figure out what execution it needs to take. So that's pretty interesting. 11 and 12. 11 is synonym. 12 is include null values. I'll just do 11 for now. I'm getting kind of SQL'd out for the day. Let me filter this. So we have 10. I'm just going to look. This is going to make it easier for me to figure out what's going on. From select view. Join data set. So these two, 13, 18 from that's 11, right? From database select view. 11, 13, 18. Let's go out on a limb here. Bah. Did I just not save this? Well, look at that. That's what I'm talking about. So we've almost effectively, at least for a basic example of a from statement with left joins, where we need to, or we basically just created a SQL generator, a script builder from data. And kind of looking at this before I sign off, I should be looking at this more often. Nope. Before I sign off, if we take things, let's say we take this. These are the data points that we use. These are the data sets that we use. What I can do is, based on the script type of what's using this, because I can go from here to, script reference, script ID. Based on this script type, let's say some of these are, you know what? Let's just go even further. Let's take the data points. Script reference, left join, script select. On script ID. Left join. Table valued function, get script tree. We have a select and an on. We want to order by. I can build index include So I can build indexes based on the code that we are writing. That is one of the pieces to this puzzle, so I can self-optimize this. I mean, this isn't too bad. Because I mean, what's my system specs really? Not bad. But for not a solid state, for a disk drive, and I don't even believe it's in the 14s. I believe it's could be a 7K, maybe even a 5K platter. This is what we're doing, building an iteration. So then what I would use for this procedure is I would actually create another procedure on top of it that would look up by key name that root value to figure out what script ID to send here to make the chain, and then I get this data set back. Well, I hope you enjoyed this live stream, a couple hours long, but very interesting piece of tech. And I will do a shortened video on this of this builder from where I am. Probably want to do 1 or 2 more live streams to really flush this out and get this built so I can move on to moving data from here, essentially to the next little project, which is to take a JSON data set with some additional parameters and figure out what needs to happen with it. Where will this data set go? So we can start moving data into a flattened version, and this piece right here is already going to help us migrate data from here, because data sets have databases attached to it. So maybe I add another data set flag that says include database and schema, or include database and one that says include schema. And the reason why I would do that is because by having those separate, know of a SQL language without a schema, that's MySQL, database.table. So that gives us more flexibility to generate more than just Microsoft t-sql, even though that's where we're starting. But hope you enjoyed this adventure with the Mad Hatter. My name is Elric, and I will see you next time. Oh, now I will see you next time.